Welcome to MWN.com. Dr. M. Wilson is happy to welcome you all. Greetings from MWN.com. Dr. M. Wilson, author, publisher, professor of commerce and management, is delighted in presenting this session. Thank you. Please subscribe the channel MWN.com. Chapter 6. Measures of Central Tendency. The statistical data collected in the field will be presented in tabular form. It is not possible to get a clear idea about the data in this form. If these data are presented in one or two numbers, it will give a clear idea about the data. It also helps for further statistical analysis. For example, if the income of 100 people in a locality is presented in one figure, it will be easy to know the level of income in the locality. The measures of central tendency are the measures to get one single number in the form of mean, median, and mode. It is otherwise called as average. Definitions. Following are the important definitions of average. 1. According to Boolean, an average is only a short way of expressing an arithmetical result. 2. Lebo defines as, the average is sometimes described as number which is typical of the whole group. 3. According to Clark and Secade, average is an attempt to find one single figure to describe whole of figures. 4. Wallace and Roberts defines as, an average is a single number describing some features of a set of data. 5. Murray R. Spiegel defines as, average is a value which is typical or representative of a set of data. It is known from the above definitions that average is a representative value of a group of data. It represents the character of the entire data. Objectives of average. The following are the important objectives of the measure of central tendency. 1. To find out one single value that represents the entire data. 2. It helps for taking policy decisions. It is convenient for taking policy decisions if the data are presented in one single value. 3. It helps for easy comparison of data. 3. Characteristics of a good average. The average should have the following characteristics. 1. The average should be easy one to understand. 2. It should be simple to calculate. 3. It should be rigidly defined. It should give only one interpretation. 4. It should represent all the data. 5. It should not be affected by the extreme values. 6. Average should be eligible for further algebraic treatment. 7. Average should have sampling stability. The sample selected for the study should be capable of giving same data when approached by different group of people. Types of average. There are three major types of the measures of central tendency, or average. They are 1. Mean, 2. Median, 3. Mode. Median and mode are known as average of position, while mean is known as mathematical average. Mean. Mean may further be classified into three types. They are 1. Arithmetic mean A, M. 2. Geometric mean G, M. 3. Harmonic mean H, M. 1. Arithmetic mean. Arithmetic mean is the most popular method of measuring the central value. It is the representative value of the entire mass of data. It is otherwise called as an average. It is calculated by dividing the sum of all the observations by the total number of the observations. Calculation of arithmetic mean. A. Arithmetic mean for individual observation. Direct method. If values are represented as x1, x2, x3, x4, x5, xn, then, where, represents arithmetic mean, represents sum of all values and n represents number of values. Arithmetic mean is calculated by adding the variables in second column and it has been divided by the total variables, that is, 10. Shortcut method. This method is based on assumed mean. The assumed mean should closely relate with the data. Deviations of the data from the assumed mean should be ascertained and the sum of deviations should be calculated. The arithmetic mean can be calculated as follows. In the formula, A represents assumed mean, represents sum of the deviations from the assumed mean. A reasonably middle value is taken as assumed mean. It is 57. All variables in the second column is deducted from 57. If variable is greater than assumed mean, its positive value. Otherwise its negative value. Total in third column is added and divided by 10. Direct method. Arithmetic mean can be calculated through direct method by applying the following formula, where f equals frequency, x equals variables, and n equals total number of observations. Each variable should be multiplied with respective frequencies. The sum of the products thus obtained should be divided by the total number of frequencies to get the arithmetic mean. It is noted from the table that first column represents variable, here its expenses, second column represents frequency, here its number of families. They are denoted as x and f respectively. Multiply x and f in respective rows and enter into the third column. and the total of it should be divided by 50 to know the arithmetic mean. Shortcut method. It is an easy method of calculating the arithmetic mean. In this method, assumed mean should be decided first. Then deviations from the assumed mean for all the variables should be calculated. These deviations should be multiplied with respective frequencies. The total of these figures, i.e., the products of deviations and frequencies, should be divided by the total frequencies to get the arithmetic mean. Formula for arithmetic mean under this method is where A equals assumed mean, D equals deviation of variables from assumed mean, XA, F equals frequency. It is noted from the table that first column represents variable, here its marks, second column represents frequency, here its number of students. They are denoted as X and F respectively. Assumed mean is taken as 45, that's the mid-value in the variables. Then subtract all variables in the respective with 45 and enter into the third column. If variable is greater than assumed mean, its positive value, and otherwise its negative value. This column is denoted as small d. Multiply D and F in respective rows and enter into the fourth column. And the total of it should be divided by 40 to know the arithmetic mean. 40 is the sum of all frequency in the second column. Arithmetic mean for continuous series. Direct method. Variables are represented by class intervals in continuous series. Each class intervals is represented with frequency. Midpoints of each class should first be calculated. It is the average of the highest value and lowest value in each class. If the class interval for marks of students in a class is 50 to 60, then the midpoint is 55. These midpoints should be multiplied with respective frequencies. Then sum of these values should be divided by the total frequencies, to know the arithmetic mean. The formula is where F equals frequency, M equals midpoint, and N equals total know of frequencies. It is noted from the table that first column represents variable, here its production, second column represents frequency, here its number of factors. They are denoted as X and F respectively. Third column represents mid-value of the class interval of first column. Represent it as small m, multiply D and M in respective rows and enter into the fourth column. And the total of it should be divided by 40 to know the arithmetic mean. 40 is the sum of all frequency in the second column. Shortcut method. In this method, the arithmetic mean should be assumed in advance. Assumed arithmetic mean may be taken either from the midpoints of the class intervals or not. Then deviations from the midpoints with the assumed mean are to be calculated. The values so calculated should be multiplied by the respective frequencies. Arithmetic mean can be calculated by dividing the sum of the values so obtained, i.e., sum of the products of deviations and frequencies with the total observations. The formula for arithmetic mean in shortcut method is represented here. A equals assumed mean, F equals frequencies, D equals deviation from midpoints, D equals M, A, N equals total number of frequencies. It is noted from the table that first column represents variable, here its marks, second column represents frequency, here its number of students. They are denoted as X and F respectively. Third column represents mid-value of the class interval of first column. Represent it as small m. In the fourth column, mid-value of each variable should be deducted from assumed mean. It's 55. This column is denoted with small d. Multiply D and M in respective rows and enter into the fifth column. And the total of it should be divided by 30 to know the arithmetic mean. 30 is the sum of all frequency in the second column. Illustration 7 should be calculated just like illustration 6. Step deviation method. In this method, a common factor should be ascertained from the class intervals. The common factor can be used to divide the product of deviations from midpoints of each observation. The formula for arithmetic mean under step deviation method is stated here. Where A equals assumed mean, F equals frequency, D equals deviation from midpoints divided by common factor, N equals total know of frequency, I equals common factor. It is noted from the table that first column represents variable, here its sales, second column represents frequency, here its number of companies. They are denoted as X and F respectively. Third column represents mid-value of the class interval of first column. Represent it as small m. In the fourth column, mid-value of each variable should be deducted from assumed mean. It's 350. This column is denoted with small d. This column represents numbers with multiplication of 100. That's 2 zeros, this can be eliminated by dividing with 100. And it would be written in fifth column. It's denoted as small d dash. Multiply D dash and F in respective rows and enter into the sixth column. And the total of it should be divided by 70 to know the arithmetic mean. 70 is the sum of all frequency in the second column. Step deviation method can also be applied in the direct method of calculating arithmetic mean of continuous series. The formula is mentioned here, where f equals frequency, m equals midpoints divided by common factor, I equals common factor. It is noted from the table that first column represents variable, here its marks, second column represents frequency, here its number of students. They are denoted as x and f respectively. Third column represents mid-value of the class interval of first column. Represented as small m. In the fourth column, mid-value of each variable should be divided by a common value, and here it's 5. This column is denoted with m dash. Multiply m dash and f in respective rows and enter into the fifth column. And the total of it should be divided by 50 to know the arithmetic mean. 50 is the sum of all frequency in the second column. It is noted from the table that first column represents variable, here its daily income, second column represents frequency, here its number of families. It is noted from the table that first column represents variable, here its daily income, second column represents frequency, here its number of families. Third column represents mid-value of the class interval of first column. Represented as small m. In the fourth column, mid-value of each variable should be deducted by 350, which is the assumed mean. This column is denoted as small d. Then such values so derived should be divided by a common value, and here it's 100. This column is denoted with d dash. Multiply d dash and f in respective rows and enter into the sixth column. And the total of it should be divided by 50 to know the arithmetic mean. 50 is the sum of all frequency in the second column. Weighted arithmetic mean. In simple arithmetic mean, equal importance is given to all the observations. Sometimes, some observations got relatively more importance than other observations. Hence, the weights for observations should be given on the basis of their relative importance. The formula under this method is where indicates the weighted arithmetic mean, x indicates the value of observations, w indicates relative weights for the observations. This method is normally used for construction of index numbers and for calculating standardized birth and death rates. The weights assigned should be unbiased 1. The values in the first three columns are as given in the illustration. Fourth column is calculated by multiplying the values in second and third columns. Calculation of combined arithmetic mean. Combined arithmetic mean of two or more related groups can be calculated as where x bar 1 2 is combined arithmetic mean. X bar 1 is arithmetic mean of the first group. X bar 2 is arithmetic mean of the second group. N1 is number of observations in the first group. N2 is number of observations in the second group. Based on this illustration, 12 is given and the solution seldom explains the way of calculation. Calculation of arithmetic mean for open-end classes. If the lower limit of the first class interval and upper limit of the last class interval are not known, it is called open-end classes. The types of open-end classes are as follows. 1. Class intervals of equal intervals. 2. Class intervals increase proportionately. 3. No consistency in class intervals. 1. Class intervals of equal intervals. In the case of equal class interval, the lowest value for the first class can be calculated by deducting the value of intervals with the upper limit of the first class. The upper limit of the last class can be calculated by adding the lower limit of the last class with class interval. Example. Below 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, above 70. In the above example, the first class is 20 to 30 and the last class is 70 to 80. 2. Class intervals increases proportionately. The proportionate value of increases should be taken into account for calculating the lower limit and upper limit in open-end classes, if the class intervals increase proportionately. Example. Below 25, 25 to 35, 35 to 50, 50 to 70, 70 to 95, above 95. Here, the first class would be 20 to 25 and the last class would be 95 to 125. 3. No consistency in class intervals. If the class intervals have no consistency, then the first class intervals can be calculated on the basis of the second class interval. The last class interval can be calculated on the basis of the last but one class interval. Example. Below 20, 20 to 30, 30 to 50, 50 to 85, 85 to 105. Above 105. Here, the first class would be 10 to 20 and the last class would be 105 to 125. Merits of arithmetic mean. 1. It is easy to calculate. 2. It is easy to understand. 3. It can be used for further mathematical analysis. 4. It helps to compare the performance of two phenomenons. 5. It represents the entire group of data in one single value. Demerits of arithmetic mean. 1. It may be affected by extreme values. 2. The qualities like intelligent, efficiency, etc., could not be studied in this method. 3. It is difficult to calculate mean for open-end frequency distribution. Thank you. Please subscribe the channel MWN.com.